I'm the CEO and founder for a company called Collide Technology, where we are focused on trying to solve common optimization problems in manufacturing.
So help us maybe understand this with a concrete example.
Our focus is on using a solution called swarm intelligence.
What is the data environment like, right? I mean, you are working with live operational data, or there's things still on spreadsheets?
It doesn't necessarily assume a high data environment. An ant doesn't have a lot of data. It doesn't assume that we have a lot of training. Is that I think a lot of AI companies are focused on trying to solve problems that people are good at, whereas we are focused on solving problems that people are bad at.
Hi, everyone. Thank you for listening to another episode of Data Innovators and Builders. Today, I'm speaking with Fred Gertz, founder and CEO of Collide Technologies. Fred, thanks for chatting with me today.
Absolute pleasure. Thanks for having us.
Fred, you have an incredible background. Tell us a little bit about Collide, and also tell us about how you got in from advanced PhD into working with Collide.
Right. So I'm the CEO and founder for a company called Collide Technology, where we are focused on trying to solve common optimization problems in manufacturing, but also in things like marketing and transportation and logistics. And our focus is on finding these areas that have been problems for a long time, in many cases that are well understood, but people have a difficulty employing. And they have issues trying to get solutions that help them or that are dynamic enough for their situations, especially for mid-size manufacturers or companies. And our focus is on using a solution called swarm intelligence to actually find optimal scenarios that we can easily feed back to their project and management teams and logistics teams to easily, get the most out of all their resources. But ultimately, we answer the question, if we have a list of resources, what is the best way to deploy them? And I think that's sort of universal across almost any company. Every company would like to get as much as they can out of what they have. And so we specialize in trying to answer that question as clearly and quickly as possible over at Collide. But it was kind of a journey. I originally, as you alluded to, my background is actually electrical engineering with a focus on nanotechnology. And originally, I was a R&D engineer. I have a PhD in electrical engineering. I studied with Sokrat Kizarov and Alexander Hitsun. Sokrat's the person who invented the modern magnetic hard drive, a very famous engineer and scientist in his own right. And my background was in trying to design better devices. I spent a lot of time in the medical industry, robotics industry, and I did not really have a strong data background. I think the only thing that made me unique is I had done a very fulfilling and informative internship in undergrad at Florida at Florida Tech, the Florida Institute of Technology, where we'd done AI for about 10 weeks, and we learned what neural networks were and support vector machines and other machine learning models, genetic algorithms. And they taught us a lot, and that stuff was in my head when I went into the real world, when I left academia to sort of join forces. And really what led me into this field wasn't so much even that I saw the potential in it. It was that I was an engineer that kept running into problems that I thought we should know the answer to. We would one part of the factory would go down, and I would say, well, look, when it went down before, how did it go down? Why causes this sort of thing? And a lot of times, sometimes very knowledgeable people would know, but other times nobody would know. And I ended up in a role where I tried to use some data techniques early in my career to hunt down problems, and ended up building a reputation in 2014 to 2015 as a guy that uses data science to solve problems. And I ended up sort of embracing that. And now, of course, the field has blown up, but that wasn't really my intention. I was just another engineer trying to solve problems. And I just happened to be a guy that solved them in a kind of very mathematical way. And it's led me to here, where now I've had a career. I was the head of data science at a large company. Now I have an AI startup. But if you'd asked me when I finished school what I'm going to do, I would not have guessed that I would be the guy that solves essentially math problems for.
Yeah, no, I think that's incredible. And that's how most entrepreneurs kind of trace their journey, right? It's a problem that you get into and you get passionate about solving that. And, as you said in your case, the market timing happens at the right time to that problem. So, that's incredibly um, fortunate when that those two things sort of come together, your passion and the market, right? So I wanted to double click on one something you mentioned in your introduction was swarm intelligence. Help us understand, what is that? How is it different from anything else we have seen?
Yeah, I mean, I would say swarm intelligence is it's a really cool field, and I highly recommend everybody read it. The Wikipedia article is a great place to start. A lot of books about it, and it's a branch of AI from the 1990s that really comes out of the field of artificial life. What does it mean to be alive? What is a digital life being? But the way I think most AI people would understand it is the majority of the artificial intelligence that you work with, whether it's a machine learning model or a neural net, is sort of based on the idea of like, how do we solve problems mimicking the way humans solve? It Humans are very good problem solvers. It's kind of the dream is that we'll get AGI and we'll have computers that can solve things lightning fast, just the way we do, and very reproducible. But in the 90s, when we had less computer power, a lot of people got interested in this field of, well, what about how other things solve problems? And one of the fields that came out of that was swarm intelligence. And that's really looking at insects, flocks of birds. And it's really trying to answer the question, how does like an ant colony build complex structures, find food, raise young, protect themselves? When there's no central intelligence there, there's no ant that knows what to do. There's no indifference to how we handle normal data science problems. There's no training data, right? There's no ant that teaches all the other ants what to do. There's no central coordinator. Each ant is not particularly intelligent, and they're able to go out and do really complicated things. And so over a period of 10 or 15 years, it's still an active field of research, but there were some really well-established algorithms that tried to replicate collective intelligence, whether in the case of boids, it's the flocking of birds, which you see in video games all the time. In the cases of things like what we try and solve, it's ant colony optimization, where we use how ants try and find food to solve NP hard problems related to transportation and logistics. Probably the most common is one called particle swarm optimization, which is based on kind of loosely defined physics, simulated anneals, but it's looking at our natural environment and looking at how it optimizes the world around it and replicating that. And that's really where swarm intelligence comes from. And I would love to say that, I'm brilliant and I figured this out myself. But honestly, in grad school, my favorite class was this class by Dr. Gerardo Benny, who's actually, if you read the Wikipedia article, the guy who came up with the term swarm intelligence. And I thought he was a brilliant guy. I thought the class was amazing. I thought it was the reason you went to grad school was to take these more high level thinking, interesting topics courses. And so it was floating around my head when I started moving into the world of optimization and trying to find solutions. And it occurred to me, why don't I try this stuff that I learned about in grad school? And it turns out still for us, very interesting solutions in that space.
Great, great. So help us maybe understand this with a concrete example, like what might be a potential sort of a problem, especially you mentioned manufacturing industry, right? Where this sort of approach um, solves a specific problem.
Yeah, I mean, I think the classic example is something like routing and logistics. So if you've got a bunch of trucks and they all have to go to different spaces, they need to hit different areas to drop off. Like, what is the ideal way to load the trucks and the routes they should take? That's a classic traveling salesman problem. And I think something that I learned early in my career that has played into this is there is no general solution, at least, for NP complete problems, right? That's essentially what all these traveling salesman problems are, these non-polynomial time problems that geometrically grow to huge problem spaces and you can never find the right combinations. It's something we run into in computer science all the time. But as an early professor told me, he referred to it as a solved problem in a presentation once. And he said, and I asked, I was like, I did not get the memo that we had solved it. And he goes, all right, let me be clear. Yeah, mathematically we have it, but from an engineering perspective, there are a lot of good approximations to this problem. And that always stuck with me when he said that. And I think the same thing here. What we find is you go into a company that's doing a lot of logistics. They're routing all their trucks and managing their inventory. Classic NP hard, NP complete type problems. It's a combination knapsack and traveling salesman. These swarm intelligence algorithms, they use the way ants try and find food. They drop little digital pheromones and they find the shortest route between things. We're able to use that to, within usually 20, 30 seconds, build out a nearly optimal route. And by not letting perfection be kind of the enemy of good, we're able to find really good solutions really quickly and solve what would be a problem that would be very difficult for a human to solve, right? We sort of focus, and I think maybe we're unique in this, in comparison to the majority of AI, is that I think a lot of AI companies are focused on trying to solve problems that people are good at, whereas we're focused on solving problems that people are bad at, right? People are not good at large scale NP complete problems. And instead of saying, we go after those because we think, well, great, if we can add that value to a company, that's a value they didn't have before. As opposed to say,
Yes.
maybe we add more value with the AI. But most of these companies, if they have a person doing that job, they have a solution. Maybe it's not the cheapest solution, maybe it's not ideal. But in our case, companies don't have a solution for this, or they don't have a very good one. And so by using these cool swarm problems, we can solve routing and logistics problems. Those are easy to see, but those same problems map into things like scheduling. How do you assign workers to tasks and when to assign them? We could solve production planning, convex optimization problems, trying to figure out the right parameters on machines and, get the best balance of reliability with throughput. All of those map into this very cool space that are, especially in the industrial area, very interesting problems that a lot of companies just haven't had the time to take a very mathematical approach to the solution.
Yeah, I think this is very fascinating. And I really like the point that with LLMs and generative AI, we are basically solving problems that humans have already solved. It's becoming more of like, can it be done automatically? Maybe can it be done with, less resources or more efficiently, right? But it is, we are not talking about the problems that aren't solved yet. And I think I appreciate you bringing that up. Like, hey, there are a whole class of problems that we aren't even solving. And why not apply our technology towards that? So one of the things that I saw on your product was you talk about Six Sigma without struggle. So maybe help break this down a little bit for us. Like, what is Six Sigma for those who are not familiar, and what is the traditional struggle with Six Sigma that you're solving?
Yeah, and I would say that's some verbiage that we're probably going to move away from, in the sense that it makes some sense for what we do and doesn't for others. And I would say largely in the community of people that improve manufacturing, I have something of a reputation as the anti Six Sigma guy. I'm not really. I think there's a lot of really good stuff with Six Sigma, but Six Sigma is essentially a group of, it's a manufacturing and I would say management style that at its core is, giving you kind of a tool chest of ways to solve problems in manufacturing. And what it's built around is this idea of, hey, if we can limit the amount of variation in our product, if we can limit the amount of variation in our production, then we can hopefully really solve most of the problems we have. Now, I think a lot of people focus on that, but if you look at the original Toyota production system, where I think this gets the most amount of original work coming out of Japan, Toyota was able to build fantastic products by taking this idea. But when you really look at that system, what it was about was understanding, both from a practical and a mathematical perspective, how parts of your process were related to each other, and then trying to get them to act the same way every time. The math for it, I think they've done a fantastic job of making the math very approachable, which is to say that it's mostly around standard deviations. If we can calculate a standard deviation, divide a little bit, you can figure out most of the metrics you need for Six Sigma. To their credit, they realized that if you could get 3 standard deviations away from your specification limits, and of course, if you have 3 standard deviations on either side, you have 6 standard deviations or 6 sigma, then you could cut your amount of failures, deviations in your product down to something like several parts per million. I think it's 3.4
Mhm.
per million per million failures. And that's huge. I mean, the average production place, if they only had 3 or 4 failures for every million products they made, they'd be ecstatic. And they give a lot of really good tools on the management side, like how do you figure out problems? How do you control data? How do you do value stream mapping and figure out how things connect to each other? I'm something of a contrarian. And when I came into manufacturing, especially in the biotech space, this was the gold standard. And I asked myself the question, what if we didn't do that? Right? Like what would be plan B? And there was a guy in Japan named Taguchi. And Taguchi, he said, and I can never find this quote, but I swear that it's a quote from him. I hope that I'm correct. He was like, your customer does not deserve a low variation product. Your customer deserves the best product you can make every time. And that really rang true with me, especially pharmaceuticals and biotech. I was like, hey, your customer doesn't care if this is low variation drug. They want good drug every time. There shouldn't be, every drug should be perfect. And his methodology for this was, hey, let's figure out our goals as a company. Maybe it's profit, maybe it's quality, maybe it's some combination of those two things. And then we will figure out how every part of our organization mathematically links to that. When you dig into that philosophy, there's a whole branch of mathematics called operations research,
Mhm.
also sometimes referred to as management science. It's essentially a operations focused subset of advanced optimization theory and algorithmic design. And his approach was, let's take this advanced mathematics, let's get these goals, and then let's make sure we understand how every part of our decision making and process design affects it. You can get these great answers when you use this. You can answer questions like, hey, if we change this parameter, we lower this pressure by 5%, how much more money will we make? What will that do to our quality? How will it affect our throughput? How will it affect our downstream? And to me, that seemed like the dream. Now, the problem, I said, why doesn't everybody do this? And the answer, why aren't we using more operations research approaches? Why aren't we using more Taguchi style methods? The math is a nightmare. I mean, it's some of the hardest math I've ever seen in my. Yeah, I mean, as you mentioned before, I mean, I have a PhD. I'm certainly not someone who hasn't taken very mathematical approaches in my career, but even I look at an operations research textbook and I'm like, there's a lot. And so I came into it knowing like, well, this is what we want. This is the gold standard. We use Six Sigma because the math I think is very approachable, and they've done a great job in marketing and getting great results. Like let's fair to Six Sigma, getting fantastic results for large organizations and through cultural redesign and giving very approachable math and techniques that everybody can understand. And that's become the de facto standard is let's use Six Sigma. And I'm very adept at Six Sigma approaches. I mean, I spend a lot of time dealing with Six Sigma shops, but knowing that we're leaving meat on the bone, like that there's profit out there, that there's better product that can be made more consistently if we just use this other stuff. And so when I started Collide, and even really before, that was the big question I was trying to answer is like, how can we make operations research more approachable, no more easily applied? And what we've tried to attack is generalizing that. So specifically to your question, what is Six Sigma? It's a methodology using statistics to reduce variation. How does that differ for what we're trying to do is we try and go even further beyond that. And we try and make it as easy as Six Sigma's been to deploy and build a star culture around where you really understand how every part of your company and organization is affecting every other part.
Yeah. Very right and very true, right? You want that sort of reliability and repeatability of the process. One thing I was curious about also was that you work with companies in manufacturing and traditional industries, right? Um, what is the data environment like, right? I mean, you are working with live operational data, or there's things still on spreadsheets. Like, Tell us a little bit about how you know deploy in that sort of a place.
It's a great question. It's all over the place. Some of these companies, look, I mean, the average manufacturing organization is doing 8, 9 figures in revenue, right? They have money. They care. More importantly, they care about how their operation runs. I mean, we've worked with other companies too, large marketing organizations and sales group, but man, I mean, you go into operations, and this is a group of very smart people that have maybe for decades really dialed in and know what they're doing. And I think maybe one thing we do better than almost every AI company is we realize we are not the magic, right? Building something and manufacturing it, that's a heroic process. Every company I go to, whether they make tortilla chips or rocket ships, man, they have done a gargantuan heroic task building a great organization. And we think we can add a little bit to it, but they do amazing work and they're all really smart people. I don't know anybody in manufacturing. I don't know a single large scale manufacturing, but yeah, I mean, some of these places are run on paper. In some of these places have advanced ERP systems where they track everything with IoT sensors. And I would say it's all over the place. I think what makes us special is one of the cool things about our approach of using swarm intelligence is it doesn't necessarily assume a high data environment. An ant doesn't have a lot of data. It doesn't assume that we have a lot of training. If I were to use a deep learning approach for a lot of these solutions, I would have to have training data. Right? I would have to know, like, this is the right answer. I'd have to know that over and over again to eventually train the model. These ant colony optimization, for example, it's combining both a search function, the way the ant finds the food, and an optimization function where it then finds the shortest route. And if you do that intelligently, understanding your space, you can go into less data mature, low data environments where, I mean, a lot of the people we're talking to now, they're on spreadsheets. And so we've designed systems where we say, okay, let's take the data you have and let's get you what we can out of that. I think that it opens up a lot of doors because one of the, what I'll call come to Jesus moments I had as a data scientist was I ran a very large, very well thought of department at my last company. But I realized we didn't get as many good results as I would like, and that we weren't always a joy to work with. And the reason for that was when you came to me and said, hey, we have this problem, essentially my first question is going to be, how much data do you have for it? Can you give me more data? And then I'm just constantly bothering you for data. Can we run engineering studies so that we can really capture this? And I realized like that's half the problem that these organizations already have is they don't have data. So I said, if we could design solutions, and they don't have to be perfect, again, don't let perfect be the enemy of gut. If we could design solutions where we could use less data, or maybe even not really any data, and get an initial result and show you some traction, it's a lot easier conversation for you to say like, hey, we brought in this company or this consultant or this solution, and it's already saving us money. Well, now why don't I invest? Now that I see what I could do, it's a lot easier for me to say, you know what, why don't we buy those IoT sensors and glue them onto our machines? Or let's put up a webcam that can look at the throughput as it's going out and measure it. Let's put together a robotic solution. It's a lot easier for me to make that investment once I see a bit of a result, once I see some ROI. Whereas the average AI project it's partially an R&D project and then partially a production project. And it always kind of comes down to like, you're going to give me a lot of data and probably a lot of money. And then you're going to hope that I come back to you with a solution that reaches your spec. And that process might take 6 months, might take a year in some cases, depending on how many engineering studies we have to do, how much we have to get more data. And so it really builds up the resistance to a lot of organizations to getting these solutions. Even if they know that's the right answer, they go, well, I have to give you $1 million and hope you're the right guy. And then you're going to come back with a solution. And I have to hope it's the solution I want. Our solution is, why do we give you not a perfect solution? It won't cost a lot. Start running it. If you love it, then talk about doing it. So, I mean, again, to your original question, it's all over the map. I mean, it's everything from paper-based records to spreadsheets, all the way to live real-time maintenance record and IoT tracking with vibration sensors. And I think it's one of the things I love about the field is we're seeing a whole spectrum of what it looks like in the real world to collect data. And in many cases, these things are mixed. Your maintenance are on paper, but you have IoT data, right? How do we bridge that gap? And I think we have a huge impact with focusing on, let's help you solve that problem. Let's give you as much ROI as we can with as little data as possible. And then you're going to be inspired to want to go down this path more.
I think that's fabulous. The approach is not like, hey, you don't have data, so we can't serve you because we can't train on your data. But instead, it is like you're able to deliver high quality solutions with the current state of things, right? Um, and comparing again with generative AI, it's that technology is well proven when it comes to do generative actions, right? I mean, whether you're generating code or you're maybe writing a piece of marketing articles or blogs and stuff like that. But what the industry is right now trying to do is to bring it to actual operational use cases. Can it actually automate a function or part of a function? And the challenge there becomes, how reliable can it be? And how do you put guardrails around that? And how do you evaluate and all of that stuff? So, in your world, as you are working with companies and taking your solution from an idea to a prototype to production, like, maybe tell us like how you approach that and to what extent some of these factors come into play, or do you have a significant advantage maybe compared to the more generative approaches?
Yeah, I mean, I think I would say our real advantage is that right now everybody at Collide has an industrial background.
Uh-huh.
And in some way, whether that was in the data science or like me, maybe a more traditional engineering design role, at least initially. And so we've validated things before. When I used to sell robots to pharmaceutical companies, we come in and we had to do IQ, OQ, PQ, installation qualification, operational qualification, and performance qualification. And I've written those documents. And so now when the first question I get, especially from a regulated environment, whether that's FDA or the Department of Defense, how are you going to validate this? Right? How do we know this is a good solution? Now, our solutions are great, that they essentially propose an optimal solution and either you can look at it and either it's better or not, right? It rarely touches something that you would need to validate. But even when it does, we validate it how we would as if it were a robot that you're going to install. And with our experience, and you can do that with generative models and traditional AI, we just have a lot of experience of setting those up and saying, all right, this area under the curve that's going to help us fit, how much risk that we want to put into the model and how much risk that the humans are going to take and how much risk that AI takes. And in many cases, we're able to very quickly come up with a very nice validation plan that somebody like the FDA would accept because we make it look like it's a piece of hardware. I think that's a huge challenge in the space. Now, generative models, I think, have the misfortune of being difficult to get metrics around, right? If you're using a generative model to say produce documentation for your process, that's a great use. I think that can add a lot of value. We've done some work in that space. I mean, it's something that could save people a lot of time. But what does it mean to be a good document, right? What is the number for that? And that, sometimes we do something with real world human judges where we say, hey, we have a bunch of people do the documents and they rate them and we use that scoring and we try and improve it and it's either good or not. Or we use LLM judges. But I think, the switch to generative AI, at the end of the day, it's not, in some ways, it's not fundamentally different than the world we had when we were all doing machine learning and doing support vector machines and small neural networks to try and just all feed forward stuff. But what's changed is all of the stuff we used to do in data science when I started out was so numerically driven. It had a metric. We, put it under these ROC curves and we would look at them and we would validate that way. But I always kind of accuse, especially LLMs and some vision models where you're generating pictures. It's sort of like we've gone into this world of data science without numbers, right? Oh, let's produce the words and then I see if the words make sense to me. And if they do, then I'm happy with the model. Now that's a little bit being flippant. I mean, they use masking techniques to see, statistically how close the vectors being generated are to the actual thing. But I think there's some truth to that, especially for smaller shops that are fine-tuning LLMs. They end up with this situation where they don't have numbers. And I'm always encouraging companies, whether they're working with us or we're giving some help out to our friends in the AI space. If you can come up with a metric of success, then that's the way to go, right? Because then you're going to know if you're improving. You're going to have agreed upon it. And a lot of companies will tell me, we don't know what the metric of success is. And my response to that is always the same. Then that should be the problem you solve. Like, solve that problem, figuring out how to measure what good is. But yeah, I mean, I think these generative models, especially in places where people have come up with metrics for them, and there's some really good ones out there, it's beautiful, right? I mean, they can provide a lot of value to a lot of organizations. And we're seeing, that world is revolutionizing how we've thought about AI. In the last 4 years, I've been in the space since, I guess you could technically say, since about 2007. We've never seen anything obviously close to this level of interest. And I think now these questions are being answered both academically and in the real world. How do we measure what good is in these? And I think some really cool solutions, whether LLM judging or inventing metrics like things like Parrot or Rouge or Blue, man, those are all headed in the right direction. I really look forward to a world where we start putting some more numbers back into our generative model.
Yeah, I think in many generative AI agentic sort of applications, the measure of good is still a human who is sort of determining that yes, the output that is coming out, let's say, is code being generated. Well, is that good? Now there are, you know, generative AI is being applied to downstream processes as well. But yeah, ultimately, what is production grade and what can go in has to be, judged by humans right now. So I agree with you that judging the outcome is not an easy sort of thing. But most use cases are a human assistance, sort of use cases in many ways, right? One question I had was, since you mentioned robots, physical AI is becoming a topic of big discussions, and looks like that is one world where, again, massive automation could become possible. What's your take on that, and what approach might work there?
I would say first, I want to say I, for one, welcome our new robot overlords. Um, and I know that gets said a lot, but I think, that's where we were headed. Before AI, right? People were putting in lights out manufacturing facilities. People were looking at things with robots. This has accelerated it. Now, there's a lot of work that has to be done. Some of it's really cool, exciting. How do we make these things safe? When I worked with robotic arms in the past, I never really appreciated, because I'm just some guy who runs numbers and would do programming on them, how heavy they were and how fast they could move and how much damage they could cause. And it wasn't until I started installing them in factories and we had to put up, safety grids and laser arrays and plexiglass that I started realizing somebody could get really hurt with one of these things. And I think those problems are, people are coming up with lighter robots, ones that are more collaborative, they're easier to train. Some guys are doing really interesting things on safety, where the robot can kind of extrapolate into situations maybe we didn't train it on or explicitly program it to avoid hurting people. I'm seeing some great stuff out here where am right now in South Carolina, where, BMW is using, robots to just, find out if people aren't wearing the right safety gear, or I think there's some really interesting aspects, jobs that people weren't great at, or you wouldn't want to put a person in, or they could get injured, that are becoming accessible. It adds a ton of reproducibility to your process, right? If you've got one robotic line, you need to make it two, you order the robots and build it out, you copy the code over, and it's good to go. With some limited validation and variation adjustment. Whereas starting a new human line, we got to get a bunch of humans together. We have to retrain them. We have to test whether that's working, and we get the throughput we get, and it's highly variable depending on like how sleepy people are and how well trained they are. So I do think that this area of physical AI is going to be a huge hit, but I almost think in a lot of ways it was already a huge hit.
Mhm.
Just people are throwing more money into it. Fauna and Stably weren't going broke even before ChatGPT. But I think now a lot of people are getting to the AI field, and much like myself, they're saying, okay, well, everybody works on LLMs. So I'm going to be an AI person. I want to work on something different. And some of those guys are going over to robotics in the same way that we've gone over to
Yeah.
intelligence. And in fact, Swarm Intelligence was highly interested in the robotics field originally. There's a ton of great swarm robotics articles from the 90s where people tried to build, ant-like guys that would build bridges automatically by interlinking. And I think the realm of physical AI is in some ways still in its infancy. That ability to see an environment and get insight out of it and then extrapolate to good decision making. I think a lot of that is going to cross over to the kind of work we do on decision making and optimization. And some of it's going to extrapolate very highly into these generative fields that really haven't made it into the physical realm yet. And I think that's going to be very powerful, exciting stuff in the next decade.
Hmm. Do you think that these LLM based agents and swarm intelligence kind of end up working together in some cases, or sort of going side by
I
side?
certainly hope so. It's an open
Uh-huh.
field of research for us, right? I mean, we
Yeah.
think we solve the kind of optimization problems that LLMs do not do well at. And we've tried. I mean, we have it tried schedules and maintenance routes, and it does terribly. Outside of it trying to essentially replicate our code and then run it and then use the results, which it does some interesting things in. But I think we're now approaching a world where you're really seeing that the LLMs are struggling. And I would say the number one place you see that is in agent coordination, right? If you have 500 agents in your company, all capable of doing different things, you end up back into our space. How do I assign tasks through? And each one of these agents only does one specific thing. These things start to look like anthills very quickly. And I think there's going to be, and there already is some great research in this. I mean, I hope that we're going to get a bigger part in it going forward in the next year. But that question of like, how does agent coordination done? And at this point in time, it's either you hard program it or you try and use a reasoning model, which they're not good at this sort of heterogeneous swarm problem. I think it's going to be a very interesting thing over the next 2 or 3 years. And I think it's going to be a really interesting world that brings in the deep learning guys that are working on reasoning models, competing with guys like me in swarm intelligence because, we're small time and we like to not have to dial up a GPU every time. The reinforcement learning guys that have been floating around in the back, figuring out how to solve problems for a long time, and probably some classic convex optimization guys. And I think we're all about to have a really exciting field over the next 3 or 4 years of borrowing from each other to find solutions that are largely to the end user just going to look like, oh, my LLM's better. And they don't realize 50 different agents touched that problem in the 5 seconds before they read the paragraph it made. And we're going to do I think it's going to be some really cool stuff between us and everyone else once we all start kind of mixing together.
Yeah, I mean, very well said. I think multi-agent coordination orchestration is complex, and you're very true, right? Like, try to put 500 of those together, things don't, work out well. So, definitely an area of research, and quite exciting to see how you're thinking that in the next few years we'll see significant advancements in that area. And I would say what a great note to bring this conversation to a close today. And super excited about what's coming. Any predictions that you want to throw in for 2026 as we wrap up?
I'm terrible at predictions. I mean, this is, I don't even play the stock market anymore. I'm such a numbers dweeb, like when I sports bet, I do that by the book, man. I've got my swarm algorithm helping me out. But I will say, I think in the next year, I mean, obviously a lot of interesting stuff is happening with agents. I think we're going to see a slowdown on the LLM side of things. I think we're already seeing it, right? There's no additional training data out there. We've trained these things on the internet. We're going to see this sort of leveling off. And I think we're going to start seeing, areas that we knew existed, we haven't dedicated as much time to, like reinforcement learning. I think optimization stuff. I mean, obviously we're betting big on that because that's who we are. But I do think it's the next year or two is going to be as we see all now. How do we get them more efficient? How do we get them training more efficiently? How do we do things like solve exactly what you alluded to before, these areas like physical AI? I think we're going to see a nice broadening of perspectives, and I'm really excited about that. I mean, not to say that I have anything against my fellow AI researchers that focus on LLMs, but I think we're all tired of it a little bit now.
That's a fair point, and I think that's kind of the history of technology, where hype and reality start to come together, and we realize that the hype maybe not as close as we think it is, at least not in the next year. But yeah, a lot of incredible innovation happening, and I'll look forward to what some of the things that you guys are bringing into the pictures. Yeah.
We hope that we're a big name in a big space any day now, but we appreciate the time you've given us today to tell a little bit about our story.
Yeah, no, thank you so much for joining me today. It's been a pleasure talking to you, and look forward to exciting stuff coming from you.
Sagar, it's been an absolute pleasure. Thank you for having me.
Thank you.